All right, today we are going to start talking about rational functions and asymptotes, in case you don't remember that word, asymptotes. We are going to continue this in section 7 as well. They blend seamlessly together. So, a rational function, the definition is just f of x is p of x over q of x, where p of x and q of x are polynomials, and q of x is not 0. And we assume that p of x and q of x have no common factors. So basically I have two functions that are divided, and the bottom can't be 0, and I can't simplify them. That's what we are assuming. So there are two types of asymptotes, horizontal and vertical. The line x equals a is a vertical asymptote of the graph if f of x approaches infinity or negative infinity as x approaches a from the right or from the left. A vertical asymptote, just a different color here, is an invisible line, right? We don't actually see it on our graph, that we cannot cross. At no point in time do we cross this vertical line. So if I have a vertical asymptote like this, that means as my graph comes in from the left or from the right, my function can either approach infinity, so it goes up like crazy, or as I come in, it could go down to a negative infinity. That's a vertical asymptote. The line y equals b is a horizontal asymptote of the graph if f of x approaches b as x approaches infinity or negative infinity. So this is also an invisible line. That the graph approaches to the left and or right. So what that means, we have this invisible line. Okay, that's my asymptote. On the far, far, far left of the graph or the far, far, far right of the graph, my function gets super, super close to it but doesn't quite touch it like that. Or maybe it's on the top side and it goes like that. It gets really, really, really close to it but not quite there. The funny thing about horizontal asymptotes is that you can cross them in the middle. So you just can't cross, just not at the ends. It gets really, really close to the ends, but not quite there. So our rational functions have asymptotes. I've got a horizontal asymptote and a vertical asymptote here. Whoop. This one just has a horizontal asymptote. This one, asymptotes are a danger to our children because if this was a slide, you were going down forever and never quite getting anywhere. So, asymptotes of rational functions. They are pretty straightforward to find. We have some very specific rules. So if f is a rational function given by this p of x over q of x, right? These are just polynomials. That's all it means. The graph will have vertical asymptotes at the zeros of q of x. So this means set the denominator equal to 0. Those are vertical asymptotes. It'll have at most one horizontal asymptote. Can't have two horizontal asymptotes. You might not have a horizontal asymptote. So if n is less than m, the x asymptote, or the x-axis, is the asymptote. Well, that means nothing unless you look up here. N is less than m. Numerator's degree is smaller than the denominator's degree. I actually think of this as numerator degree is smaller. Then the x-asymptote is the x-axis is the asymptote. That means y equals 0 is our horizontal asymptote. If n equals m, so that means same degree, the line y equals a sub n over b sub m is the asymptote. Looking back at my function, a sub n, b sub m, we just simplify the leading coefficients. Y equals fraction We got a number over a number. Simplify leading coefficients. There we go. And if n is greater than m, there is no horizontal asymptote. So if the numerator degree is bigger, there is no horizontal asymptote if the numerator has a bigger degree. So let's find some horizontal asymptotes. Horizontal asymptotes. All right, that means we look at the degrees. In this one, the degree of the numerator is 1. The degree of the denominator is 2. The numerator has a smaller degree, so that means the horizontal asymptote is 0. In this second one, g of x, the degree of the numerator is 2. The degree of the denominator is 2. They have the same degree. So our asymptote is y equals, take the leading coefficient of the top, leading coefficient of the bottom as a fraction, simplify if needed. Boom, there it is. And for h of x, the degree of the numerator is 3. The degree of the denominator is 2. The numerator has a bigger degree, so there is no horizontal asymptote. All right, let's find all of the asymptotes now. Well, vertical and horizontal. To find vertical asymptotes, we'll do that first. We set the denominator equal to 0. So x squared minus x minus 6 equals 0. We factor x minus 3, x plus 2. So that means x equals positive 3 and x equals negative 2 are my vertical asymptotes. For the horizontal, let's use this color. We look at the degree. The degree of the numerator is 2. The degree of the denominator is 2. They have equal degrees. So my line will be y equals leading coefficient of the numerator is 1 over leading coefficient of the denominator is 1. My horizontal asymptote is y equals 1. And finally, f of x. Here we go. We set our denominator equal to 0 to get the vertical asymptotes. So x squared minus 1 equals 0. Add my 1, x squared equals 1, square root, x equals plus or minus 1. We could also factor the x squared minus 1, either way. So our vertical asymptotes are at x equals 1 and x equals negative 1. Yes, you have to write both of them out. They are separate lines. And for our horizontal, we look at the degree of the numerator, which is 2. The degree of the denominator is 2, so we have equal degrees. So our asymptote is y equals leading coefficient of the numerator is 2 over leading coefficient of the denominator is 1. My horizontal asymptote is y equals 2. So remember that with the graph, for example, this one. If I have vertical asymptotes at positive 3 and negative 2, all right, if this is my graph, at positive 3, I have an invisible line that I won't cross. At negative 2, there's another invisible line that I won't cross. And at y equals 1, that just tells me what I do at the ends. This says nothing about what the middles do. We'll get into that. But the middle could look something like, ooh, right? We approach it on the far left, we approach the horizontal, can't cross this one. Maybe it does something like this in the middle. And maybe this side looks like this. I don't actually know, I didn't do the work to do this, but remember it won't cross your vertical asymptotes. Horizontal asymptotes are what you approach at the ends. You can cross them in the middle though.